Hey guys, been a long time since we did a video. Been super busy at work and life in general anyways. So what I was gonna do here is, I've had a few questions on the D3. I think there's still some kind of confusion out there as to how to really set this up, especially with the endpoints. So I was gonna go through that and just a little bit about how I set it up. Again, there's a few ways to do this, I'm sure. This is just how I do it. So not set in stone, but give you some tips. So I got my 32 here with me. So I'll do it on the 32. It would really apply to any radio. I'm going to use a 7108 S-Bus receiver to show you this. So again, if you got a 7006, 7003, 7008, all exactly the same. You're gonna need a connector like this to do it this way. It's kind of a male to male with all of at least your signal line coming out. You don't necessarily have to have the negative and the positive, but you definitely will need the signal line. Now you're gonna need something to power your receiver with. I got a Thunder Power 900 pack here. Shameless plug, best packs in the business. You're gonna need something to power your device. I'm just using a 4S little drone pack. And I've got an ISDT BG8S here to do the output measurement. There's other devices that do this. This is kind of handy because not only does it measure pack voltage, to check in between flights, but it's got some features like this to do, to do some checks on your receivers. So how do you set this up? Well, it's pretty straightforward. First thing you do is really just power up your BAT-Go or your ISDT battery checker. And then really you want to plug your connector here, your male to male, into the throttle channel. In this case, it's channel 3, it's default from Futawa. And we're going to energize that receiver up. I've already linked it to the transmitter, so you don't necessarily need to use the receiver in the plane to do this. All we're really doing is measuring the receiver output. So if you want to confirm that, yes, I'm getting full throttle, you can go ahead and just use any receiver you got sitting around. It'll give you the same result. And then we're going to take that connector here and we're going to plug it into this battery checker. So we're going to connect the negative up to the negative. You can kind of see there's a negative at the top here. So we're just going to connect it into there. The pin spacing is about right to fit this, so it will go in. So that's good. So we're set up now. We got receiver, linked to the transmitter. It's energized. We got power to this guy. Away we go. So we're going to hold down this button, or press it, I guess, to get into the function menu, and you're going to do a receiver tester. This is where we're going to go in there. And it's going to give you two options, PWM or S-Bus. Throttle output is PWM, so it's just a pulse modulating output. So that's what we want to measure. If you can't select S-Bus because you won't get any reading. So we're going to pick that, and you should get an output. So you'll see there I've got an output on mine. So if you slide the throttle up and down, it's going to move, right? And so that's going to tell you exactly what the pulse width output is on that channel. You can do this on any channel, generally not terribly relevant, unless you're setting up speed controls with fixed endpoints, which is what the D3 is. So we got that. That's fine and dandy. You guys are probably going, okay, that's cool. What do I do? So Adam includes, a set of instructions with his controllers. And in there, kind of right at the top, it basically says, your receiver output should pulse, 1,000 microseconds for closed and 2,000 for full, right? So that's really what you're trying to target here. So you'll see in this case, I'm at idle, I got 1,000 output. I go to full, I got 2,000 output. So that's really what we're trying to get to. So what you want to do, and for the idle, I find is less critical because you're going to adjust that as you see fit for your own, flying style and braking. So you'll probably run that higher. For the arming, obviously it needs to be low enough that you can arm it. So if you don't get it down to 1,000, you probably won't arm it. But for full throttle, you obviously don't want that too low or too high. If it's too high, you'll lose top end resolution on your stick. You'll hit full throttle early. If it's too high, you won't, or too low, you won't ever hit full throttle, right? So you'll be pushing full throttle, or the controller will try to go to full throttle and it won't be able to. So in the Futaba, right, there's a few on the 32, the 18, the 16, the 18 SE, all the same. I do have a glass of Chianti here to keep myself entertained in the garage, just if anybody's curious what that was. So in here, we're going to go to endpoint. That's kind of your primary method. Now, I have 114 and 100 in here set up. So I'm going to skip out of there for a second, and I'm going to go back. Before we get too far, let's make sure our AFR is correct, right? So we want to basically have AFR at 100. And I have this in a landing. I'm going to flip to my normal flight condition. So you'll notice in this, I actually have rate B set to 80. So rate B is the top half of the curve, because I have it offset to 20. So if I was to offset this to 0, obviously this would be 100. So my AFR is set to 100. I did not adjust that. So you could kind of manipulate this in AFR. I choose to leave these endpoints, especially in the top end, just at 100 because it's simple to remember. So that's, I guess, first point to note is that AFR is at 100 in this setup. So let's go back to linkage. I have no sub-trim in here. Where is it here? Right there. So I don't have any sub-trim on throttle. My trim doesn't affect the full throttle. So really it's just that AFR and the ATV. And so my AFR is set to 100. So my ATV is 114. So what you would do, and obviously I've already adjusted this, but what you would do is you'd have that at full throttle. You'd be watching, it would start out at 1941 microseconds. That would be your output on a default setup. You're just starting from scratch. So you're going to increase this, and watch that pulse width go up. And we're going to do this basically until that gets to 2000. And I mean, if you're 1996 or you're, 2004, does it really matter? Probably not. You want to get it as close as you can. So that's essentially the top end. On the bottom end, I just leave it to 100 because that you can do all in the AFR. That's pretty simple. And the reason for that is because the way I set it up is I use multiple conditions. You'll notice in my various flight modes, the top is all the same, but the bottom is different. So for instance, this is my normal flying mode. If I go to idle, I'm not at 1,000, I'm at 1,119 because that's kind of where my RPM is spinning. That's about 14, 15, 1600 RPM, give or take, on the Plenty Advanced. So I've adjusted this rate A, the low end, to kind of give me that setting that I want for flying, right? And that's with the trim. Trim obviously affects this too. There's a few things that affect it. That's where the trim's at 12, plus 12. So it's kind of down 3/4 of the way. So you got about 3 things going on here in the low end. So it's not as critical, to hit that 1,000, except in your arming mode or your landing condition or somewhere, you need to be able to get that down. So there's my 1,000. So obviously I can get that down below to arm it. So if I start my transmitter up in normal, it won't arm. If I flip that to landing, it's going to arm, and I'm going to trim up to basically get that motor spinning, right? And then when I take off, I'm going to go back to my normal flight. That's kind of how I have it set up. So again, you need a condition, or you need a throttle cut or some method like that to bring that down to 1,000 microseconds, right? So whether you want to use that condition and some trim, or you want to use throttle cut, or whatever method you want to do to get there, Every radio is going to be a little bit different if you're JR or if you have or Jetty or whatever. But the point is, you need some mechanism to get down to that 1,000 so you can arm it. And then really for your low end throttle, wherever you want to fly it, you know, the D3 is constant RPM. So if this is 1,500 RPM, it's going to try to hold that RPM in the downline, which would give you braking. If you turn that up to 2,000, you're going to get a little less downline braking. If you slow down a bit, you probably get a little bit more. Spins and such, you know, I have a slightly different setting for a spin, right? It drops a little bit because I find my normal flying idle a little too high, right? Stall turns doesn't change, snaps and stuff obviously doesn't change. So really I have kind of three. I have normal, landing, which is quite a bit lower, and then spins. And normally when I'm flying, I have this trim right at neutral. That's sort of where I have it set. So my normal flying, I guess, for idle is 1,200 microseconds. And then my landing idle is 1,080, and then I can trim it down to arm it and shut the motor off. That's essentially how I do it. So super handy device for setting this up. I know I went through it pretty quick here, and maybe I'll just flip to these conditions. So there's the normal. You can see all the rate settings that I'm using in normal. Right, so again, I leave that top at 80. I got an offset of 20 in there. You know, and I just adjust that exponential to kind of get my mid-stick throttle correct. I suppose if you want to look at that, you know, I'm running mid-stick throttle of 1,824. So it's pretty near, it's pretty up there. It's, you know, kind of 3/4 of the way to full stick, basically. And then, yeah, so normal, I got obviously a slight adjustment in spins. So really, I don't know why that offset drops, but, you know, really it just drops that low end down just a hair. And then in landing, obviously I drop it down quite a bit just to make sure I can arm it. And you know, and I really cut that down to idle to nothing, right? Just to give you tons of braking on landing if you need it. Most of the time I got to carry a bit of power coming into land, just because it's kind of too aggressive. Yeah, so that's really about it for setting up the D3. And then, like I say, anytime you want to reset up a new radio, you can use this, or you can just copy these across. I find, you know, transmitter to transmitter, it's pretty consistent. I've used this 114 and an 18 MZ, the 32 MZ. It gives me the same result. So I haven't tried it on an 18 SC to see if it's the same, but I'm sure it's pretty close. So that's really it for setting up the D3. Hopefully that kind of clarifies a few things up as to how you can do it. And yeah, I guess if you got any questions, shoot me a PM on Facebook or a message, and I can try to answer them. Anyways, hope you enjoyed that, and we'll see you next time.